So what we're looking at right now is the cameras. We have, this is the overhead camera that we're looking at right now. And you can see it's now facing close to 45 degrees down. And, you know, I can see the other camera here, which is indicated by this X, Y, and Z. And the other camera is here. So let's take a look at the whole thing. So that's the overhead camera we're looking at right now. Now we look at the left camera. Not seeing a whole lot there because it's just sitting by its side. We're using Gr00t. And there's the right camera. I'm going to point the right camera down and left camera down just slightly so that we can get a better view here. So we would rotate this axis downward just a little bit, a hair. So we've gone through our 700 steps, so it finished after 700 steps, and that's step 0. And I wanted to show you that to start with, so we're not fiddling with these things later on. Setting cameras, pretty interesting. You know, I thought I knew a lot about it, and I knew a lot for Isaac Sim, but for Isaac Lab, you're resetting the cameras again, and maybe that'll change in the future. You do all this work in Isaac Sim, you expect it to propagate over to Isaac Lab, or at least somewhat relatively easy. I bet there is an extension out there that does that already. Somebody knows, drop it in the comments. But anyway, there are these parameters sitting here. Where do they come from? If you go to sensors, I'm looking at Nvidia documentation for Isaac Sim 5.1. And so if you go here and you go to cameras, sensors cameras, it'll kind of give you a good indication of all of these different parameters and attributes. One of the main ones is setting the data types that are supported, and you can see and this is a tiled camera. You can also set this up to be just a generic camera, but this is a tiled camera. These are the available attributes here. And what I do for the depth camera, especially I'm using in Luxonis OAK-D Pro, it has a lot of these available to it. But for normal operation, we're going to use the RGB and depth. So I'm collecting distance to image plane and this one. And then we can also get semantic segmentation if we wanted to as well. So I'm collecting all of those things. I'm only printing the RGB. And another thing and this is what it looks like. The normal RGB, and then we see depth and distance here, and then the semantic segmentation. Those are the things that I think are important. The other thing is setting up where the camera is. So here you can see, and I know most of these parameters, there's a couple that I don't know. And actually this is a good place for the code assistant to come in and help us here. So I asked it, okay, focal length. I wanted to know, like, how do I really set focal length? So if I went with a small value, could I see more of what's in front of the camera? An even smaller value will help you do that. And then, and so I wanted to know that, and I wanted to know what the depth of field, and that's focus distance. So that's like how far away before things start blurring out and kind of, and in this particular case, we're interested in the things that happen right in front of the camera, but we're also interested in mimicking the camera exactly that we have. So if I have a Luxonis OAK-D Pro, I'm going to have these settings kind of fixed for that, because in the real world, I want the camera from the simulator to match the camera from the real world. So I would go to Luxonis's website, to OAK-D Pro, and get these settings. And some of these settings are settable, but you can see this is the one that I have. I have the autofocus camera, and it goes through, you know, all the settings that are available to it. So This is the ideal depth range, 70 centimeters to 12 meters, which is plenty. And you can set all these. And then it has object tracking, so it's an object tracking node, those kinds of things. Some of these are not going to be that useful to Gr00t. We're again running Gr00t, so at least to start with. So there are some things that are not as important as others. So I'm just going to go ahead and use the things that are important to me. And you can buy this camera for about $3.99. I'm sure you can find it used on the sites where you can look for used stuff. But then another interesting thing here is you can take a look at, here's the field of view for the autofocus cameras, the one I have. I actually have all of them, or most of them. But and then the focus length 8 centimeters, frame rate 60, right? Effective focal length 4.81 millimeters. So these are important numbers to know, because I don't want to train in my simulator for anything that's not realistic. And so same thing. So a great use of the code assistant is to say, like, say I don't know what any of this stuff is. I can just go say, what do these parameters mean? And it already knows about the website that we were just on. And so what I'll do is just let it tell me, okay, what do I have here? And rather than just accept the things that are there, or have to go deep looking for these different attributes. So here we go. So I said focal length 8. What does that actually mean? What does the clipping range mean? So let's just go over it real quick, and that'll be basically what we're doing for right now. So this is the focal length, the distance in millimeters between the lens and the image sensor. So basically, how far away from the camera can you see? And so this is a wide angle lens. It allows the camera to see a large area of the workspace. Okay, and then the focus distance is the distance, usually in meters, at which objects are perfectly sharp. So 400 meters, quite a large distance. We don't need that. That's 400 meters is far beyond what this is capable of. And so I can change this focus distance down to say, let's say, I think 12 was the max in meters. That's as far as we need to see. So that's the focal plane. And then the next one, clipping range, is the visibility limits of the camera. So near plane, which is the clipping range I have set, objects closer than 1.1 meters to the camera will be invisible, so clipped. That's not what we want it. We want it to be lower than that, seeing inside the camera's geometry itself. But 0.1 meters, that's we can go less than that and still get the objects that we want. And then far plane, objects further than 20 meters away will not be rendered, which is great because we can't see 20 meters away anyway. So and in that way there's no like simulating something that actually can't happen. What is the physical, so horizontal aperture, the physical width of the simulated camera sensor in millimeters. So what I could do with all this information is I can bring back another great thing of the code assistant is I can say, how does this settings, or these settings, I guess, compare to my actual camera? And I actually don't type. I use the microphone. I'm super lazy. I don't even type anymore at all. Compare to my actual camera, the Luxonis Oak D Pro autofocus. And I'm going to supply the URL of the camera. So let's just go off and see. I'm not asking, even though it's an agent mode, I've specified to not change any code, because I hate when code changes happen that I didn't ask for, but I do like them when they're automated when I want them to be. So I'll say usually after the you know, the code assistant has summarized, then I'll say something like, don't make any code changes, tell me how this works. Like for instance, I wanted to calculate this rotation for a 45-degree angle exactly. It gave me the wrong rotation because it has no idea that it's, you know, the camera is facing one way or the other until it checks that for itself. But I wanted to know how the rotation worked. So this is a quaternion, which I know all about from spatial computing and from robotics, but you know, they're often different. So here, this is very interesting. It's telling me that the sensor size is 3 times larger, capturing more light and detail than real hardware. That's bad. The focal length is, the sensor sizes are different. So I maybe want to change that. The field of view, I have it set to ultra wide, but sees more of the room. Rear camera has narrower focus. So all of these things are important. We want to change all of this. The real camera can adjust dynamically. Your simulation is fixed at 4 meters. Well, you know, whatever. And then 4 meters is actually not bad. I thought this was, it said meters when I read through the documentation, but this is actually 400 is actually 4 meters. And then the aspect ratio is square. This is a standard photo. Real sensor is like this. So if I wanted to change to the Gr00t Pro, let's just do it and see what happens. This might not be good, but I mean, I can always go right back to the way it was. So I'm just going to copy this, and we're going to go and change it. Now, again, it might not be good. I do a lot of you know, saving of my work. So I mean, that's one thing that I do. I think I screwed up somewhere. Yeah, it should have been just that. Yeah, no, that's right. You know, you know, that's one thing that I do to ensure that anything that I've just worked on doesn't get overwritten by this thing. And then also you can accept, if you go into agent mode, you can accept all the changes that are being made. This is not an overview of something that should be trivial for folks right now. So let's see it. We just looked at the beginning, you know, what the cameras looked like before. Let's try it again. So I'm going to pause the video. I'm going to start the simulator, and then we'll come back. So here we're back. You know, I'm going to move this out of the way here, and you can see that Gr00t automatically tries to go to this location. It's never going to reach the location for a number of reasons, which I'll fix shortly. But the point of this one is to get the cameras right first before we start working on anything else. And so now if we look at this overhead camera, move that out of the way. This is more indicative of what the real robot, with the real camera is just going to see when we have the field of view set up and all the things set up just like the Gr00t Pro has. So great to have the simulator and have this cool stuff going in simulator, but if it's not exactly what the actual real live robot is going to see, then we're wasting our time. So even before I 3D print the housing for the camera, I want to make sure that the camera is going to see what the simulator is going to see, or one way or the other, you know, one way or the other. Either if it's hardwired, I've already built the camera out, then I want the simulator to match the camera, and vice versa. So with here, what I'm going to do is, now that I have these kind of settings, I'm going to angle the camera down just a little bit, and you know, this is a more realistic field of view. And then now we can see the other cameras haven't changed. This is the left camera. I haven't changed anything there, which I am going to change slightly because I want to see the grippers just a little bit. So I'm going to angle all the cameras slightly down. And there's the perspective again. oh, it already hit its 720 steps as I set it for. But I'm going to angle the rotation down just slightly here, and then maybe let's try 20. And then same thing for the rotation on the, I'm going to change that to about 9. I might put it back, but I don't like to make too many changes of things all at once with this kind of precarious system that I've set up. So let's run it again. So we're back again. It's running. There's the movement from the Gr00t. Still not making it up to where this is, but we're going to get there shortly. That's not a big deal. And now, while we're here, is to check out the cameras. Okay, first thing I notice is that the camera is angled upward instead of downward, so that's a mistake. And then let's check out these. That means all of them are off by that much. Yep. So I did exactly the opposite of what I should have done. But I can see I'm actually looking more at the cube here than I was before, even though the cameras are going to be facing down to needs to be facing down to the grippers more, not here. Okay, so let's stop it. We're going to do exactly the opposite of what we did before. So instead of 9, we're going to have 5, 5, and the rotation we want 05. Should be about right. Save that, run it again, pause again, run again. And we're back. So we're going to run the whole thing, the thing again. Next time we're going to look at the actual images that are created. So here we have the arm moving up toward the camera again, toward the box again. And if we look at the overhead camera, much better. So I'm seeing more of the whole scene. This is kind of what would happen in reality. And maybe, the other thing I would do is maybe pull the camera up just slightly, because this is actually not that realistic, compared to the actual camera. And that, in reality, is I'm going to measure where the camera currently is and move the actual physical, the simulated camera up to where the actual camera is. And I can change where the camera is, no big deal. It's just a matter of 3D printing or create a little adjustable bracket. But here, let's look at the left camera. That's better. And the right camera, a little bit better. Seeing a little bit of the gripper there in the camera. So I haven't modified the settings for those cameras to match yet either. So I'm not going to do a whole lot of changes, because I'm only working on that main camera, not the gripper ones, because the settings for these cameras, the right and left wrist camera, I'm 100% sure are wrong, as I have not done anything besides use the default settings that I found. So before I make a whole lot of changes in here, and figure out this quaternion, I'm going to modify these things, the focal length, the clipping range, and all the other stuff that needs to be modified. But let's just take a look real quick, and you can see could be slightly tedious to do this. So plan, I don't know, first time 6 hours to get your robot matching the simulator is a little bit easier, because the physical robot is kind of stuck and built. But if you haven't built anything and you're looking for like optimum positions, especially for some of these models like Gr00t, then you have the option to go into simulator first, decide what camera you want to use in the simulator rather than buy a real one. I happen to have a bunch of OpenArm Pros, and I have some Z cameras as well, and I've got some Intel RealSenses, so I can choose between my camera if I don't like some settings. The other thing I can do is position the camera where I want it in simulator before I actually 3D print or build or even manufacture a camera bracket that might be static. It won't be able to move. So here, here's the overhead view at the start, which is, I like this. I might, again, like I said, raise it up just a little bit. This is perfect. I see a little bit of that object, and this is the operating range for the robot. So, and it's going to have wheels, and it's going to be able to move. So once the object is in frame, in the operating range of these arms, I'll stop the robot from moving and then be able to pick up this object here, over here on this side. That's exactly what I want. Maybe I'll raise it up a little bit, and then I can use these real numbers back when I 3D print the housing for my camera that I know I'm going to use. So this wrist cameras, again, I'm seeing a little bit of the grippers, exactly what I want. Same thing on this one, a little bit of the gripper, exactly what I want. I'm kind of angled down perfectly. And you notice the rendered camera is different than the images going to the yeah, and you definitely want to take this out when you send these images to the you know, the model that you're going to use, the policy. So let's go a little bit further in so we can see what the overhead's now looking like when it's moved out to where we want it to be. There it is, and this is covering the cube. The cube is right here. You can see a little bit of it right there. But this is exactly what we want. We want the camera to see everything in the frame. This arm moves back for some reason because we're using the dominant hand in Gr00t to move this one, but I haven't told it to move this one anywhere. And so we look at the right wrist. There we see exactly what we want. There's the cube. There is the gripper, and we want to keep this kind of the same. This is the perfect spot, so I don't want to move anything. Probably going to save these settings just as they are. So everything is looking right, and just to verify later on in further steps, you still see the cube here. Perfect, exactly what you want to see, or at least what I want to see. And we'll leave it like this. So I think this is a long enough video. Definitely, it's probably too long. People stop watching after maybe like the first minute. So I hope the format of showing you what we're going to do helps. And those of you that made it to the end, please like and subscribe. And I'm trying to keep this as nerdy as possible and not go for clickbait. And you know, then I'll start showing robots and you know, precarious settings to get the clickbait. I don't want to do that. I want to keep this as scientific as possible. So if you like this, and I definitely suggest you using the code assistance for at least explainability. Tell me what's going on. Okay, so I'm going to do the same thing for the other cameras, and then we'll be all set, and then we'll focus on making the Gr00t model actually pick up the object. Catch you later.